For our virtual today, we're going to be looking at trapezoids and kites. So you may want to pause the video here and jot down the definition and properties of a kite. I would recommend that you do that on your property sheet that we got at the beginning of the module, or you can fit them into your note guide here. That's up to you. So a kite is a quadrilateral with two pairs of consecutive sides congruent and none of its opposite sides congruent. Now for me, when I look at these four properties, they're going to start to get a little confusing here just because of the letters that we're using. So I would definitely write down property 1, and then all the other properties I think we can show in the picture. So first and foremost, if diagonals are perpendicular, I know that there's a 90-degree angle happening right there where those diagonals meet. I also know that this consecutive side is congruent to this one, meaning the sides right next to each other. And this side is congruent to this one. What this basically does is it splits this kite into two sets of congruent triangles. So on the left, we have two sets of congruent triangles here, which means that this segment is the same as this one. And it also tells us we've also got 90-degree angles here and here. When I look at the right side of this picture, I've got two congruent triangles here as well, which tells me again, I've got a 90-degree here, and those segments in the middle there are bisected. The other part of that it tells us is that we've got congruent angles here and here. As well as on the other side, we have congruent angles here and here. So there's a lot of info on there. So what I'm going to do is I'm going to erase all of our markings that we have and put them all in one color so we can see what that looks like visually. So we've got all 90-degree angles all around the center. This segment is equal to this one, which means these angles are equal and these angles are equal. It also tells me that this segment is the same as this one. On the other side, we've got congruent segments here, congruent angles here, and here. So what we're going to look for each time we solve these problems is we're going to look for the pairs of congruent triangles so that we've got two sets of identical figures. So looking at this kite, they want to know what is the measure of angles 1, 2, and 3. So what I'm going to do first is highlight the two triangles that are the same. So I know that those two are my two congruent triangles. And angle 1, since my diagonals are perpendicular, has to be 90 degrees. With that, since the triangle on the right is simply reflected to create the triangle on the left, I also automatically know that angle 3 is also 52 degrees. But to find angle 2, I know that all of my angles inside of that triangle have to add up to 180. So 180 minus 90 minus 52 is going to leave me with 38 degrees. Try picture 2 on your own, then check your answer. Again, because our diagonals are perpendicular, angle 1 there has to be 90. Since our two congruent triangles are here this time, meaning the one on the bottom is reflected up to create the one above, angle 3 is also 36. And the measure of angle 2 we can find by knowing that we have 90, 36, and an unknown. So 180 minus 90 minus 36 is going to leave me with 54. As far as kites go, we're typically going to see pictures that either look like 15 or 18 that you see here. So one thing that we want to also remember is that kites, because they're four-sided, all of their angles have to add up to 360. And angle 1 and this angle here will always be the same. And the reason for that is if I sketch this diagonal here and this diagonal here, I know this angle is the same as this one, and this angle is the same as this one. So put together, they should both be 110 since the original angle is 110. So the measure of angle 1 is 110 degrees. Now remember, like I said, all of our angles have to add up to 360. So what I'm going to do is I'm going to take 360 minus the 3 angles that I have. So minus 110, minus 110, minus 98. And whatever is left over is my measure of angle 2. Take a look at number 18, mark everything you know, and I'm going to grab a calculator. So looking at number 18, we should know automatically that we've got a 90-degree angle right there in the center, because we know that these are always perpendicular to each other. So angle 1, without a doubt, here is 90 degrees. Beyond that, I want to look for my congruent triangles. So I've got 2 congruent triangles right here, which means this angle is also 55. And then if I can do 180 minus that 90 minus that 55, that's going to leave me with 35 degrees for angle 2. That also means that angle 3 is 35 as well, because we know that this is just a reflection of that triangle on the right. At the bottom, we have our other set of congruent triangles. So we still have our 90-degree angle here. Angle 5 is automatically going to be 62. And then to find angle 4, we're going to take 180 minus 90 minus 63 to find out how much is left over, which is going to be 27 degrees. Again, angle 5 is just 62. Now we're going to shift into talking about a trapezoid. So again, I would recommend that you write this on your property sheet. So a trapezoid is a quadrilateral, meaning a 4-sided figure, with one pair of opposite sides parallel. Pause the video if you need to jot that down. Specifically, we're going to focus on an isosceles trapezoid because it has more properties to deal with. So what an isosceles trapezoid is we've got these parallel sides, but our non-parallel sides are congruent to each other. We call those 2 congruent sides the legs, and the bases are the 2 sides that are parallel. Now when this happens, this kind of splits your trapezoid into an upper base section and a lower base section, meaning the 2 angles that are considered your lower base are always congruent, and your 2 angles that are considered your upper base will be congruent as well. The other key component here are these last 2 pieces, so I would make sure that you jot those down in your properties chart as well. Our diagonals are congruent, and any lower base is supplementary to any upper base. Make sure that you got the picture and the definitions, pause the video if you need to, and then resume it when you're ready. So within this isosceles trapezoid, like I said, it's going to split it into upper base and lower base. So if we look at that, angle 1 is also 109 because those are both along the same base. Whereas to find 2 and 3, we're going to need to subtract from 180 because any upper base and any lower base have to be supplementary. So angles 2 and 3 are both 71. Looking at number 7, now we're trying to solve for this variable here. Since both of those are along the same base, 117 would have to equal 3n. And then I'm going to divide both sides by 3 to get an n value of 39. Last but not least, we know that these diagonals within an isosceles trapezoid are congruent, which means that x plus 5, which is given up here, should be equal to 2x minus 2. If I solve that for x, I end up with an x value of 7. The last little thing we're going to talk about here is called a mid-segment of a trapezoid. And we've talked about mid-segments before when we talked about triangles. We said that it's one midpoint joined to the other. And within a triangle, that mid-segment, all we had to do was double the midsegment to set it equal to the base. However, now, within a trapezoid, we have two bases. We have the base up top and the base at the bottom. So if we double the midsegment, it's now equal to the sum of the bases, meaning we're going to add them together. Pause the video here if you need it to take these notes. So looking at our examples here, we know that QR is a midsegment, which means if I double my midsegment, it should equal the sum of my bases. So therefore, 2 times x plus 2 should equal 4x minus 10 plus 8. So distributing that to 2x plus 4 equals 4x minus 2. I'm going to subtract the 2x from both sides and add the 2 to both sides. And lastly, divide by that coefficient of 2 to get an x value of 3. Now what you might want to get in the habit of doing is plugging that back in, meaning for LM I have 4 times 3 minus 10, which means I have 12 minus 10, which is 2. In the middle I have 3 plus 2, which is 5. And last but not least, I have 8. And what you should notice here is there's a consistent increase. We're increasing by the same amount to get to the next level. That will always be the case, that we are increasing by the same amount. Now it may not always be 3, but we should have the same amount between each level. So you've got a couple of practice problems here. I'm going to do number 4 with you. Then I'm going to recommend that you try 5 on your own. So we always want to double the midsegment and set it equal to the sum of the bases, meaning we're adding them together. Distribute our 2, subtract our 2x from both sides, add our 12 to both sides, and then we can solve for that x value by dividing by 4, which gives us an x value of 9. Notice in our directions here, though, it asks us to find GH. So I need to go back to that midsegment and say GH would equal 3 times 9 minus 6. So I've got 27 minus 6, which is 21. Go ahead and try 5 on your own. Pause the video and then come back to check. So you should end up with an x value of 3 and a GH of 13. For the last two parts here, it says find the lengths of the segments with variable expressions. So now we're trying to find all 3 segment lengths, but the same basic principle. We're always going to double the midsegment and set it equal to the sum of the bases. At this point, since we've done several of these, I'm going to stop the video here. You can go ahead and work on your practice for today. Remember that tomorrow will be a review day, and then we will take our test on Thursday. Have a great day.